morning, everyone. Welcome to today's class.
Pencil. I want you to tell the message given by the pencil. So, what are the messages can you give with pencil? Message, good messages. For example, okay, pencil. What is the use of pencil? So, pencil can say, I can write your thoughts on the paper. Okay, what you think I can write on the paper. Okay, so that is one message. Okay, like that you can use your creative thinking, and then you can tell what are the messages that you can say with pencil. So it's your creative thinking. You can draw. Very good. Yeah, you can draw. I can draw. What you can draw using pencil?
Sir, pictures.
Yeah, picture. What picture you like? You have to say what is the picture. What picture you like? There are many pictures, no?
Tree, car.
Okay. Very good, very good. What else? What are the other messages?
Sir, if the pencil speaks, it will say that I give my life to express your thoughts.
Very good, very good. I give my I give my life to express your thoughts. Okay, very good. Any other answers?
Sir, we can write with pencil homework.
Wow, yeah, pencil can say you. I am helping you in writing your homework. Okay. What else? What else, ma? What else your pencil can say?
Sir, we can correct our mistakes.
Super. How will you correct your mistakes using pencil?
Sir, by erase it and writing again.
Very good, ma. Shogit is on fire today. Okay, getting many answers from Shogit. What are the other answers? Interesting answers are coming. You can erase your mistakes using pencil. Very good, very good. Okay, what are the other answers?
It will help us to write letter.
Letters. Very good, Vishnu. You can write letter.
May say conductor of electricity.
You can. I can conduct electricity. What is the material that conducts electricity?
Sir, it does not.
Pencil, what it conducts electricity? It will conduct or it will not conduct?
Not conduct, sir.
Not conduct.
Yes, sir.
Okay, there is one thing in pencil called inside that graphite is there, no?
Yes, sir.
Graphite conducts?
Electricity.
Yes, graphite conducts electricity, but outside it will not conduct. Very good. Very good answer. Very good. Very good. Interesting answers are coming. Okay, I want a few more answers.
Sir, we can train our hand with pencil.
Very good. Yeah, the early ages, every baby starts with a pencil. Okay, then only you can say like this also. I can teach you how to write. Right? So we are learning writing using pencils. It's very useful for everyone. Everyone use the pencil, isn't it? It's a very good message. Okay, super, ma. One more is there. Okay, ma. Okay, tell.
We can.
It can say that I help you in maths for geometry.
Okay, so mostly for geometry and all, we'll use only pencils. Okay, in diagram, in geometry, also maths and all, if you want to learn, you will use pencils. Super. Okay, you can say lots of.
We can use any temperature in
We can use pencil in any temperature. Very good, ma. Yes. So that is also one of the interesting answer. So one more thing is there. Okay, I'll tell my answer. So for pencil, inside is more important than the outside. Okay, so outside it will go, but inside that graphite only, using graphite only we are writing. So for a person, the inside what you have is very important, not the outward appearance. Outward appearance is less important than the inward. So what you have, what is inside you have the knowledge, inside you have the good character, inside you have the good thinking. That is very important for a person instead of outward look. Okay, that is also a message from the pencil. So pencil, the inside thing is very important than the outside. Okay, so that is also a good message that you can take from the pencil. Very good session, very good interacting. We got a lot of answers, new answers from you. Okay, now we move to the today's class. So today is very interesting and final day. Okay, we will see what you can learn. The two things we are going to learn today. The first one is parking system. Second one is dustbin. So we are going to build a parking system, automatic parking system. No need any security force to check whether the space is empty or not. So all those things are done by automatic using this ESP32 board. So the components that is needed is breadboard, servo motor, ultrasonic motor, and then we need ESP32. Okay, you have to tell me what is the working of gear motor. Can you remember gear motor that we used in the robotic car?
Sir, it reduces the speed and increases the torque.
Yes, reduces the speed and increases the torque. Whereas the DC motor, if you give the supply, it will rotate at the high speed. The maximum speed it will rotate. Okay, if you give the maximum supply, it will rotate at maximum speed. Using potentiometer, if you control the supply, it will reduce. Okay, reduce the speed. So that also you have done. And then another motor that we learn is gear motor. So what is the use of gear motor? Means so we should not need a maximum speed. It should be somewhat less speed because it has to turn in the left as well as in the right. For that we need a gear setup inside that. Okay. And so when you have the gear setup inside the motor, then you can able to turn to the left, turn to the right with the help of. So that's turning as done. The turning thing is called torque. So torque is the force that is used for turning. Okay, RPM is revolutions per minute. Okay, so that is RPM. Okay, so we have learned that already. And we have the ultrasonic sensor also. That what is the use of ultrasonic sensor? It is used to
calculate the distance and detect torque.
So when it will send the ultrasonic signal. Okay, it's high frequency signal. We cannot hear the sound. Ultrasonic sound we can't hear, but it is there because it is very high frequency. It will hit the object or the obstacles, and then the signal will be feedback. Okay, reflect back into the ultrasonic sensor. So that's why it is called sensor. It senses the signal. It sends the signal, and then the reflected signal will be sensed by the echo pin. Okay, we have two pin, trigger and echo pin. So and then it will calculate the time taken for the signal to travel to the object, and then the time it takes from the object to the sensor. So it calculates the distance, calculates the time. Based on that time, it will calculate the distance. So based on the distance, we can use this ultrasonic sensor in different applications, in the security, in the alarm system. Okay, so automatic light. So when the person is entering, the light should be on. The person is leaving the hall, the light should be off. We can use it in many applications, these ultrasonic sensors. Okay, it's very useful sensor. So, and this is the servo motor. So you can see on the in your kit there will be one motor called servo motor that is blue in color. Okay, inside this also you will have you can see here there is this is the fan or the load. Okay, so this is the output one, and here you can fix whatever you want. Okay, and then inside that what is there means you have a DC motor, again have a gear setup. So this is the gear setup, but this is of different gear setup, not that gear setup that we have used in that. And this is of potentiometer, we call it as potentiometer. Okay, so these are the things that you have. So the definition, so what is this servo motor will do? We have three components here. So this is, you know what is the potentiometer? It will control the electricity power. Okay, so we can control use the potentiometer to control the speed of the rotation, isn't it? So that part also there inside. So this is the overall setup. Okay, we cannot see what is inside, but you can see using this picture. Okay, so you can see the definition. You can write this definition for servo motor. A servo motor is a rotary actuator. Okay, rotary means rotating part. Rotor is there, no? like that rotary actuator. Why it is called actuator means based on the power supply it will rotate. Okay, based on the amount of power supply only it will rotate. So it is not rotating continuously. So if it is rotating continuously, then you can say it's a rotor. Okay. So inside the DC motor, the rotor is rotating continuously. But this servo motor at the output is not rotating continuously. It will rotate for certain angle. Okay. So that's why it is called rotatory actuatory, that allows for precise control angular position. Okay. Precise control of angular position. So this is very, very important. Okay. In some cases, okay, where you are you can see in some applications, if you want to lift something, robotic arm. Can you see the robot? How the robot will walk? Hello, you have seen some robot, no? Robotic picture and all. You can see how the robot will walk.
Sir, by moving its hands and legs.
Yeah, how it will move? The hands and legs. It will move step by step, but it will take the object in a certain angle, right? Okay, in a certain position. That it will by step it will go down, and then it will go left to the right. Okay, so it will move in a slow motion. Okay, we have seen that, right? Okay, when it gives a handshake also, it will come one by one, and then it will go front, go back. Okay, all these things are controlled by a angular position. Okay, so that is the use of this one. Okay, so it will work in an angle. When you are doing this experiment, you will understand how this motor will work when compared to the gear motor as well as the DC motor. Okay, you have to keep this in mind. So write this line on your notebook. A servo motor is a rotary actuator that allows for precise control of angular position. Okay, precise control of angular position. So that is the thing. The servo motor is used for precise control of angular position. When you want to move in an angular position, 90 degree, 180 degree, like that you want to move, then you can use servo motor. Okay, that's why the name called servo motor. It will move in an angle, first 90 degree, then another 90 degree, like that it will move based on the power supply. That's why inside that you have DC motor. It is controlled by gear potentiometer and then gearbox. Okay, at the output this will move in an angular position. So the output is in the form of angular position. It's not rotating continuously. Okay, so shall I move to the next slide? Okay, so how this motor will work is, if you give a 1 millisecond supply. Okay, that means this is called PWM, pulse width modulation. Okay, inside that when you give the VCC supply, I have a okay, we will give the pulse called pulse width. We have that means your servo motor is controlled by a pulse width modulation wave. Okay, so what this will do is when the pulse width is 1 millisecond. Okay, it is on for 1 millisecond and then it is off, means it is in the angular rotation that is given by the servo motor is 0 degree. Okay, and then if you give 1.5 millisecond means it moves to 90 degree rotation. Okay, for 2 millisecond means 180 degree rotation. For 2.5 millisecond means another 90 degree, 270 degree. So like that it will rotate for every 0.5 milliseconds, 90 degree, 90 degree, 90 degree. So that is called angular rotation. Okay, so we are not giving any input pulse here. We will give only the power supply and the control signal. Inside that you will have a feedback. Okay, so comparator and feedback setup will be there. That will generate this pulse. Okay, so using that pulse only, your servo motor will be controlled. Output is only 0 degree, 90 degree and 80 degree. So while discussing the code, we will see this. Okay, so as of now we will go for the connection. Okay, the connection is very simple. Okay, you have to take the breadboard and then you have to fix this ultrasonic sensor like this. Okay, like this you have to connect your ultrasonic sensor and then seven jumper wire, male to female, you have to take. So one end it will be like this, another end it will be short, and then you have to fix the 4 wire lines on the ultrasonic sensors here at the back of the breadboard. So here only it is connected. Behind that you are connecting. Okay. So this is the servo motor. You have 3 wires here, and one is ground, another one is VCC, third one is control signal. Okay. Finally, we have to connect this based on the spin diagram, and the connection is over. Then you can see the demo. So you can see the working of this. Okay. Take your breadboard, everyone.
Breadboard and ultrasonic sensor. You will want to take breadboard and ultrasonic sensor. Ultrasonic வந்து breadboard வந்து fix பண்ணிக்கணும். Next வந்து 4 jumper wire, female to male connections. And female to male connections வந்து male தான் breadboard வந்து கனெக்ட் பண்ண போறீங்க. ஓகேங்களா? எப்படின்னா அல்ட்ராசோனிக் ஒரு 4 connections இருக்குல்ல, same line fix பண்ணணும்.
Okay, so first you have to connect 4 pins on the breadboard. Okay, after that the 4 wires you have to take. Okay, you have to insert that male connector on the breadboard on that 4 pins of the ultrasonic sensor. So that is the connection. All the 4 pins you have to connect with 4 wires, one by one. Okay, so then you can proceed, sir.
Next connect female pin to ESP32. Ultrasonic to VCC வந்து 5 volt கனெக்ட் பண்ணிப்பாங்க. 5 volt VCC வந்து 5 volt. Next trig and echo. Trig board number 5. Next echo pin board number 8. Ground connect to ground. Okay, எல்லாரும் finish பண்ணிட்டீங்கன்னா thumbs up பண்ணுங்க. Next வந்து servo motor. It is VCC ground yellow output. Okay. First VCC fixed plug-in 3.3 volt. VCC plug-in 3.3 volt. Then brown color plug-in. Servo 3 wires and ultrasonic 4 wires. Next output pin. We connect load number 2. Servo fix பண்ணுங்க like this. This type இந்த மாடல்ல வந்து fix பண்ணுங்க. ஓகேங்களா?
So it's very interesting application. So as usual, first you have to go to File and New Sketch. Go to New Sketch. It will open like this, and go to select the board.
Select other boards and board. Search ESP32 space dev space module. Click it to insert the USB in your laptop.
See, whenever you want to upload anything onto your ESP32 board. So ESP32 board has a memory, right? Okay. Yesterday you did one program. Today you are going to do another program. So what you have to do is, you have to do the same step. Go to the Arduino IDE, and then open the new sketch, and then select the board, and then insert your ESP32 onto the laptop, and that port will be get selected. Once you give OK, your board and the system is connected. You can copy and paste the code on this one, and then verify, and then you can upload it. So you have to do this process whenever you want to change the code. When you want to change the code and the operation of the application, you have to do this process. Okay, are you able to understand? Okay, this is the common step you have to do whenever you want to upload the code on the ESP32. Once you uploaded that, you can use that ESP. You can disconnect with the laptop, and then you can use the ESP32 separately. Okay, so remember this step. This step is common step. Okay, so now we will discuss about the code. So we are including a library called ESP32 servo.h. Since we are going to use servo motor, that library function we are including in this module. Okay, in this program. After that, we have 3 pins here: trigger pin, echo pin, servo pin. Servo pin means what is the color of the wire, sir?
Yellow, sir.
Yellow. Okay, the yellow pin that is in the servo motor called servo pin. Okay, so that we have connected to ESP32 second pin. Okay, so these are the pin number we are maintaining. That if you want to change also you can change, but the code also you have to change the same thing. And here you can see constant. You know what is const? So constant. So before that we have used the define, but here we are using constant. So what is the difference? What is the use of constant here is this is a constant integer. Int is nothing but an integer. It's a number. So the value that is coming out of this trigger pin and the echo pin and the servo pin will not change. Okay, especially from the it will be maintained constant throughout the program. Okay, intermediate it will not change. Okay, when you are doing some application means we are maintaining this values constant throughout this project. So that is the idea behind it. Okay, it is not a variable, it is a constant value that you are maintaining at the trigger pin, echo pin and servo pin throughout the program. So that is the thing as mentioned here. And then we are creating a servo is the class. Okay, we are creating a variable name my servo. Okay, we are creating a variable name my servo, this class servo. So that's what servo, my servo. And then long, I already said it's a big number. Whenever you are measuring the time, we have to use long integer. Okay, so we have different, double is there, integer is there. So long means 4 bytes, double means 2 bytes, integer means single byte number. Okay, so integer 1 byte is 8 bit. So all those things you have to remember. 1 byte is 8 bit. So if you write, you can, it's good. 1 byte is 8 bit. Double means 16 bit. 2 bytes, that means 16 bit. Okay. Long means 4 bytes. That means 32 bits number. Okay, so that's what this data type is mentioned. So far you understand what are the terms that we are using on the code. Setup. So setup means whenever you have a function called setup, we are going to tell to the ESP32 that pin is either output pin or input pin. So you have to mention that. Okay, because you can use GPIO means general purpose input and output pin. Okay, you can use pin in the ESP32 as an input pin or output pin. So we have to mention that using this setup function. So we have setup, we are creating a setup function, and then pin mode. Okay, so that is also a function. And then trigger pin. What are the pins that we are using is trigger pin, echo pin and servo pin. So trigger pin is an output pin. It is common. We know that in the ultrasonic sensor. Echo pin is input pin. Servo pin, we are not mentioning as an input and output pin. What we are doing is we are attach the servo pin. Okay, we are attaching the servo pin to the my servo. So I will explain you what is this, what it is doing at the later part of the code. Okay, so we are attaching the servo pin to the motor. So my servo is the motor. We are attaching that to the motor. So that's what the connection is. The connection is we are giving that to the motor, and then we will see what is there happening. Okay, so my servo is the motor, and we are attaching that servo pin. And what we are going to do is we are going to write the value into the servo pin. Okay, so we have seen different types of timing in the pulse width modulation diagram. It's 1 millisecond means 0 degree, and 1.5 millisecond is 90 degree rotation. 2 millisecond means 180 degree rotations. Like that we have seen in the introduction class today. So similarly, we have to give the value into that thing, whether 0 degree, 90 degree or 180 degree. We have to give that value into that thing. Okay. So initially we are making that position as 0 degree. Okay, that's the initial position. So 0 here represents 0 degree. And then we are serial communication that we are doing. If we are connecting the LCD, this will be very useful. Okay. Void loop. So loop is a loop function is it will do the process continuously. Okay, it is not doing one time, it is doing continuously, repeated times. If you want to do one task means we have to go to the loop. Okay, so digital write means we are giving trigger pin low signal. Low means 0. Okay, and then we are waiting for 2 microseconds. After this, we are making the trigger pin to high. Okay, how much time? 10 microseconds. Okay, and then again we are making the trigger pin to low. So you can see when you do this, you will have a pulse like this, isn't it? So initially low and then high for 10 microseconds, and then again it is low. So this is the pulse that we are used to generate the ultrasonic wave that will pass and hit the object. Okay, and then it will going to come back, and that will be received on the echo pin. Okay, pulse in echo pin. Okay, so and that will be high. So So we are receiving that on the echo pin. Based on that, we are calculating the duration. Okay. So this is the common code that wherever you are using ultrasonic sensor, this code is common. The only thing is you can vary this to 10, you can vary. Otherwise, you can maintain the same timing. So just below, just go down, sir. Again, you have a distance equal to duration into 0.034. I will explain this. This is nothing but the sound waves, frequency, time taken for the sound waves to travel in the air. Okay, and divided by 2 because it is going underneath the object and it's coming back. So twice the time it is taking. So divided by 2, and the duration that is calculated by the sensor. So when you multiply that, you will get distance. Okay, and then serial input distance, and then these are for the displays, and then comes from the when distance is less than threshold. Okay, so when the distance is less than threshold, what you are going to do is it will write 90 degree. Okay, it will write 90 degree, else it is not changing. So 90 degree means your servo motor is moving from 0 degree to 90 degree. That means the gate is opening. Okay, and then if there is an object, if there is no object, again the gate is closed. Else the gate is not moving, it is there. Then again it sends the signal from the ultrasonic pulses, and it is detects. It will open the servo motor to 90 degree, okay, angle, and then if it is not there, again it is closed. Okay, so that is the working of this one. So it's like a gate, open, close, like that it is going to operate. And then after every loop, so first one loop is over, after half a second, that means 500 a year, if the value you put, it is converted into half a millisecond or half a second, and then again the loop will run, So for every half second, the ultrasonic wave sends the signal and it gets back. If there is an object, it will open. Or object means what? If there is a car, it's waiting, it will open. Otherwise, it is closed. So like that, it will do. Okay. So that is the working of this code. Do you have any doubt?
Sir, what is threshold, sir?
What is
Threshold.
Okay, threshold is the value that we are based on this value that we are giving. No, okay. So, for example, there we have fixed specifically as 30 centimeter like that. Okay,
sir.
But here we are not fixing that value. We are saying that it is a threshold. Okay, based on this values that we are sending. No, it is 20 centimeter around that. So the threshold value is 20 centimeter. 20 centimeter, it will measure the 20 centimeter. Based on the values that we are giving in our code, it takes the values as threshold. Okay. So we are giving 10 centimeter, no? For example, 10 milliseconds we are giving for the trigger to move and come back. So if you are not mentioning any values, means you can give the threshold. Okay. It will take the values automatically. So here for our case, it is 20 centimeters for the values that you are giving. Otherwise, you can give the specific value. Okay. So that's it about that. Okay. Now we can move to the execution part.
It's a verify completed to click upload. ஆப்ஜெக்ட் மூவ் ஆகிற வரைக்குமே கேட் வந்து ஓப்பன் தான் சார். ஆப்ஜெக்ட் வந்து மூவ் ஆகிற வரைக்குமே கேட் வந்து ஓப்பன் ஆகும். ஒன்ஸ் ஆப்ஜெக்ட் வந்து மூவ் ஆனதுக்கு அப்புறம் தான் கேட் வந்து க்ளோஸ் ஆகும்.
Okay, so now we can see. Come sir, very good sir. Oh, let's look at that. Okay, it's a simple one. So what are the other applications that we can do with this?
Toll gate, sir.
Toll gate. Okay, another applications. So okay, tell me, you can say, what are the other applications that you can use with this servo motor? Because, this servo motor, you are using a heavy servo motor, means it will move a heavy object. Okay, so we are using small servo motor, so it will lift some small amount of weight. Now we move to the next project, automatic dustbin. The operation is same. So here we are using this application for opening the gate and closing the gate. And the next thing is we are going to use opening and closing the dustbin. When the person is near to the dustbin will open automatically, and after filling that, it will close automatically. So that is the working of dustbin. So sir, can you show the demo?
So okay sir, same pin number, nothing changes sir. So fix the
Same thing. You don't need to do anything. Only thing is we are changing the application. Okay, make this setup ready. Okay,
first ultrasonic வந்து fix பண்ணுங்க sir. Center of the dustbin.
it's the ultrasonic sensor like this on the cardboard.
Center
Using
of
double tape. Center of the cardboard. Imagine that cardboard is nothing but your dustbin.
Next to connect the pins. Female to female sir. Take 4 jumper wire into female. One end to connect the ultrasonic sensor. Another end connect to ESP32. Same connections. First VCC to 5 volt. Same connection. VCC connect to 5 volt. Next, click pin. Trigger to connect board number 5. Board number 5 to connect trigger. Next step. ஃபர்ஸ்ட் வந்து அல்ட்ராசோனிக் வந்து ஃபிக்ஸ் பண்ணிக்கணும். சென்டர் ஆஃப் டஸ்ட்பின் ஓகேவா. ஃபிக்ஸ் பண்ணதுக்கப்புறம் ஜம்பர் ஒயர் வந்து ஃபீமேல் டு ஃபீமேல் ஜம்பர் ஒயர் கொடுத்துங்க 4. பிசிசி வந்து 5 வோல்ட். நெக்ஸ்ட் டிகர் பின் வந்து போர்ட் நம்பர் 5. தென் எக்கோ பின் போர்ட் நம்பர் 18. ஓகே, போர்ட் நம்பர் 18. நெக்ஸ்ட் கிரவுண்ட் டு கனெக்ட் கிரவுண்டிங் ESP32 GND. ஓகேவா, ஃபினிஷ்டா.
The same pin number. No need to change anything. Just as you are changing the location of the ultrasonic sensor. Instead of breadboard, you are connecting that on the, pasting that on the cardboard. That's the only thing. Other connections are same. If it's difficult for you to connect with the laptop to the ESP board, you can disconnect the laptop wire and then you can give a battery supply to the 5 volt. Negative to the ground of the battery supply and the positive to the 5 volt.
Next step, fix the servo motor. Next, fix the servo. Holding. Okay, like this. To fix the servo, to connect wire or thread, your wish.
That is the top of the dustbin.
Next to go for connections. In servo, the same thing. VCC to connect 3.3 volt. Then ground to connect the ground. Last output to connect pin number 2.
The connection is same.
Same connections.
To the previous experiment.
Next
Okay.
demo session.
Okay, show the
Same
demo.
code also. Code also same sir.
Yes. Code also same. Okay, show the demo. Okay, very good, sir. Is that good? Okay, and when we are going near to that, then sir, it will open. Okay, so
We are coming to the end of the section. Thank you.